Hello again. We are back, and what are you saying, Grogo? What? Oh yeah, only one talk left. So that means that you have last choice, last chance, sorry, to participate in our Kahoot challenge and win IntelliJ license. And also, don't forget, please, to go to the page. Talk page and to rate our speakers. This is really important. So please rate their talks, send them pages, and of course, you can send pages to org team as well. Really highly appreciated. Thank you very much. And thanks for being with us through all this day, quite full of talks and stuff. But I do hope you enjoy our conference. So please let us know in the chat. And we are moving to our last, but unf- uh, absolutely not least speaker. So it's easy. It's easy for me because the name is same. So our next speaker, Andres Ortiz. Andres, hola, bienvenido, Javon. Andres, can you hear us?
Hola, hello everybody.
Uh,
Hey,
yeah. So
can you hear me now?
we have some. Yes, it looks better. Okay, we now can hear you. Okay, seems all good. Okay, cool. So let's not waste time. So you can share your screen meanwhile, and we will dive right into your topic. Meanwhile, guys, let me remind you last time for today that you can use both chats to write your questions. So you have chat on VR community platform, you have a chat in YouTube. So you can use both of them to write your questions. I monitor both of them and will ask your questions to our speakers in the end of the talk. Um, yeah, just a reminder again about Kahoot challenge and reminder about rating for our speakers, and all the recordings of all our talks will be available on YouTube and on on VR community platform. On our community platform, yeah, also sounds good. Right after the conference, so you can rewatch it anytime. Okay, so Andres, good luck and let's go.
Thank you, Roman. Great. Good morning or good afternoon, everybody. And thank you all for joining me today for this exciting session. My name is Andres Ortiz, and I am thrilled to be here to talk about a topic that directly impacts how we, as developers and engineers, adapt to this ever evolving world of technology. As many of you know, Java has been a cornerstone of software development for decades. It powers millions of applications across the globe and continues to grow and adapt to meet new challenges. But as we head toward 2030, the landscape is shifting rapidly, especially with the rise of Gen AI, new frameworks, cloud computing, and other emerging technologies. So, why talk about this subject now? Well, the intersection of Java and Gen AI is one that has already started to profoundly change how we approach software development. Tools like GitHub Copilot, ChatGPT, and other AI assisted tools are transforming the way developers write code. This is a streamlining repetitive tasks, helping us debug faster, and even assisting in design decisions. So these innovations are reshaping expectations for engineers and are altering the very fabric of how applications are architected. At the same time, Java continues to evolve. As we move to an era dominated by cloud native development, serverless computing, edge systems, IoT, and of course, Gen AI. Java still remains critical for enterprise tech ecosystems, but we must adapt and innovate to stay ahead. In today's talk, we'll cover the following key areas: the current state of Java and how it's shaping modern software development as of 2025, the rise of Gen AI tools and the profound impact they are having on our workflows, what Java developers need to know to thrive in the next decade. We'll also include predictions for how Java and its ecosystems and the role of the developer in the 2030. I will include the main challenge of integrating Gen AI with Java development. and finalize with a discussion on how you should prepare for opportunities and the risk of these technologies. So let's dive in. And before we get started, this presentation reflects my personal opinions and interpretations. This is based on real data, statistics, and research, though. The views expressed here do not necessarily represent those of any organization or entity. I encourage you all to think about how tools like GenAI have already impacted your development workflows. Feel free to share your thoughts or questions during the Q&A. And remember, we're here to learn from each other. So let's kick things off by looking at where Java stands today in the evolving software development landscape. So let's start taking a closer look at Java's place in 2025. You know, Java is a programming language that has stood the test of time and continues to evolve as technologies advances. Java has been one of the most widely used languages for nearly 3 decades, and its versatility, reliability, and scalability have made it a cornerstone of modern software systems. But the question we want to ask today is how Java has adapted to the challenges and opportunities of today's tech ecosystems, particularly in areas like cloud native computing, security, and of course, artificial intelligence. So in this section, we'll explore the Java's current role in software development, some key trends and innovations shaping its future, and how Java fits into the AI-powered world of 2025. First, let's take a snapshot of Java's current place in modern development as of today. Java remains one of the most trusted tools for building robust and scalable applications. And Java was released 30 years ago, and short after its release, it has been ranking amongst the top most used programming languages, having today the largest community in software development with more than 7 million developers. They use Java for things like enterprise systems, such as enterprise resource planning or customer relationship management, um, cloud native architectures powering microservices that are agile, scalable, and fault tolerant, big data analytics platform like Hadoop and Spark, which provide insights at scale to business, and Android development, where Java's legacy as the foundation for mobile application continues, even though Kotlin has grown in popularity in the last years. So why is Java still so dominant? Because it maintains three qualities that are essential for modern systems. First, platform independence. Remember the slogan, write once, run anywhere? This still matters in globalized distributed systems. Second, scalability. Java powers systems that can handle millions of transactions daily. And third, security. Industries like finance and healthcare trust Java for applications requiring strict compliance and safety. So as you can see, Java is central to many of the technologies shaping how business innovate in 2025. But the story doesn't end with where Java is today. Java's growth over the past few years has been driven by 4 groundbreaking projects that are transforming its core DNA. These projects are making it even more suited for modern, high-demand applications. And those projects are, first, the Project Loom. The Project Loom introduces virtual threads, making concurrency far lighter and simpler for developers. Instead of dealing with the complexity of traditional threading, which is resource-heavy, Loom offers lightweight threads that allow high scalability with minimal performance overhead. Imagine a server handling thousands or even millions of simultaneous requests. Loom makes that seamless. the project Panama. Panama bridges the gap between Java and native libraries that could be written in C or other high performance languages. This allows developers to scale applications while tapping into the power of native systems. This is especially impactful for areas like machine learning and data intensive applications where speed is critical. Project Valhalla. Valhalla focuses on introducing value types, a new kind of a data structure that is cheaper to create and faster to process. So instead of the heavy cost of objects, value types make large-scale data processing far more efficient. Valhalla is a game changer for industries like finance and gaming that increasingly depend on real-time calculations. Lastly, GraalVM. GraalVM let Java developers compile their code into native binaries. This run blazingly fast while being lighter and more resource efficient. GraalVM is also multi-language, meaning Java can integrate seamlessly with other languages, for example, Python or JavaScript in diverse development environments. This is redefining what Java can achieve in high-performance systems. These four projects, Loom, Panama, Valhalla, and GraalVM, are not just technical upgrades. They are turning Java into a language fit for the demands of AI, cloud-native systems, and edge computing in 2025 and beyond. Java has a long history of adapting to major shifts in the software landscape. Before the rise of serverless, Java applications were typically designed for long-running monolithic servers. This made them less suitable for the short-lived, event-driven nature of serverless computing. So, to address this, the Java ecosystems introduced innovations like GraalVM and Project Leiden. This significantly improved the startup times and reduced memory usage. New frameworks like Quarkus and Micronaut emerged, and those frameworks are especially optimized for cloud-native and serverless workloads. As a result, Java today is now a viable and efficient choice for serverless platforms like AWS Lambda and Azure Functions, just to mention some of them. This evolution demonstrates Java's ability to adapt and thrive through major technological changes. Now, let's connect Java evolution to one of the most exciting areas of technology, artificial intelligence. Many people often ask, what role does Java play in the AI space, especially compared to a language like Python? Well, here's a quote that summarizes the difference perfectly. Python trains the models, Java takes them to the real world. Why does this make sense? Today, Python is the preferred language for research, experimentation, and model development in AI. We have libraries like TensorFlow, PyTorch, and scikit-learn that make it incredibly flexible for training machine learning models. And not only that, also building neural networks and handling data science workflows. But that's just the first step. When those models need to be deployed in secure and production-ready systems, especially in certain industries like healthcare, finance, or other heavily regulated industries, Java becomes the clear choice. Just to give you some examples, in finance, AI models detecting fraudulent transactions are integrated into Java-based core banking systems. In healthcare, models assistance in patient diagnosis are deployed in Java applications that meet strict compliance standards. And in enterprise systems, Java ensures AI models are scalable across distributed environments and compatible with high volume workloads. This partnership between Python and Java, trained with one, scaled with the other, ensures organizations can innovate responsibly while maintaining reliability and operational excellence. To sum it up, by 2025, Java is not only a legacy programming language, but also a forward-looking platform that is pivotal to some of the world's most advanced technologies, including AI, cloud-native architectures, and other emerging technologies. Organizations depends on Java because of its versatility, security, and scalability. And its evolution only makes Java ready to meet the demands of the next decade. Okay, so now that we have established where Java stands today, let's explore the force that's reshaping our entire industry, generative AI. We're not talking here about another development tool or framework update. We're witnessing a fundamental shift in how software is conceived. Before we dive in, I would like to ask you, do you think AI will impact Java development? I will try to answer that question during this section. So let's dive into how Gen AI is reshaping the tools, workflows, and roles in software engineering. And let me start with a striking example of just how capable AI has become. This graph here shows AI performance on GPQA Diamond. This GPQA Diamond test is a set of PhD level science questions that requires deep reasoning and expert knowledge. And what you are seeing here is remarkable. We have moved from AI systems that could barely handle basic questions near July 2023 to models that can handle PhD level scientific problems with increasing accuracy as of today, just nearly 2 years later. But here's what this means for software development. If AI today can reason through complex scientific problems, it can certainly understand code architecture, debug complex problems, and suggest optimizations that will take human developers hours to identify. This isn't about replacing human expertise, it's about augmenting it. When AI can operate at this level of reasoning, it becomes a true partner, especially in the development process, and not another sophisticated autocomplete tool. The implications for Java development are profound. We're talking about AI that can understand enterprise architecture patterns, suggest performance optimizations, and even help with complex refactoring across large code bases. Now, let's look at the trends driving this AI revolution. I have 4 metrics that tell the story of unprecedented technological acceleration. First, train compute is doubling every 5.3 months since 2020. If you analyze this is in Moore's law. This is exponential growth on steroids. The computational power being thrown at AI training is growing at a rate we have never seen in computing history. Second, algorithmic improvements are equally dramatic. The physical compute required to achieve a given performance in language models is declining at a rate of 3 times per year. What this means is that we're getting better results with less hardware. And efficiency is improving as fast as raw power. But here is the reality check. And this is crucial for enterprise planning. The cost of training frontier models has grown by 3.5 times per year since 2020. We're talking about a cost that has gone from millions to hundreds of millions of dollars for cutting edge models. And fourth, the acquisition cost of training hardware has grown by 2.5 times per year since 2016. The specialized chips needed for AI training are becoming exponentially more expensive. But what does all of this mean for Java developers and enterprises? Well, the good news is that AI capabilities are advancing and increasingly speed. And efficiency improvements mean you don't need the latest, most expensive model to get significant value. The companies building these frontier models, OpenAI, Anthropic, Google, and others, are already making massive investments that individual enterprises can match. But you don't really need to. You can leverage their investments through APIs and fine-tuned models. For software development specifically, this means we'll see increasingly sophisticated coded assistants. But the real value will come from models fine-tuned for enterprise Java patterns and not necessarily the biggest, most expensive models. Well, throughout history, technological revolutions have fundamentally changed how we work and create. As an example, the Industrial Revolution introduced mechanization to manufacturing. This replaced manual labor with machines. And this shift didn't just make factories more efficient, it created entirely new industries, transformed economies, and required workers to learn new skills to operate and maintain the new machinery. A direct example from that era is the introduction of the assembly line. Before its invention, products were crafted by hand, one at a time. The assembly line automated repetitive tasks, allowing workers to focus on specialized roles and dramatically increasing output. This not only improved productivity, but also made complex products like automobiles more accessible to everyone. Compared to today, we're witnessing a similar transformation in software development with the rise of Gen AI. Just as the assembly line that was used to automate physical tasks, Gen AI is automating knowledge work. Developers now have access to tools that can generate code, refactor existing code, and even design entire software architectures. Those tasks that once took hours or days can now be accomplished in minutes, freeing up developers to focus on higher level problem solving and innovation. Both revolutions share a common thread. They drive efficiency, reshape job roles, and open up new possibilities. The Industrial Revolution redefined manufacturing, and now Gen AI is redefining software development. As we adapt to those changes, we're challenged to learn new skills, rethink traditional workflows, and embrace the opportunities that automation brings. Ultimately, just as mechanization empowers workers to build more and build better, Gen AI is empowering developers to create faster, smarter, and with greater impact than ever before. So, how are developers actually using Gen AI today? Let me break this down into four key areas where we're seeing real impact. First, code generation. This is probably the most visible use case. Developers are using AI to generate boilerplate code, create method implementations, or even scaffold entire classes. In Java development, this means generating Spring Boot controllers, JPA entities, and unit test templates in seconds rather than minutes. Debugging has been transformed. AI can analyze stack traces, suggest root causes, and even propose fixes. I have seen developers paste complex Java exceptions into AI tools and get actionable debugging steps that would have taken hours of investigation. And let me digress for a moment here. A personal experience of mine, I was working in a previous project, maintaining legacy applications in a code base very complex with a lot of spaghetti code and bad practices that nobody really know how it worked. With the use of AI for debugging, we were able to reduce the average lead time of defects by a rate of 3. And as you can imagine, this is a game changer when you can achieve such results. Third, refactoring and optimization. This is where AI really shines. It can identify code smells, suggest design pattern improvements, and optimize performance bottlenecks. The AI can see patterns across thousands of files that would be impossible for a human to track manually. For documentation, perhaps the most universally appreciated use case. AI can generate Java doc comments, README files, and technical documentation that actually stays in sync with code changes. This means no more outdated documentation because updating it is now effortless. But here is the key insight. These aren't just separate tools. They are becoming integrated into our development workflows. We're talking about that the future isn't about switching between your IDE and an AI tool. It's about AI being embedded directly into your development environment. Um, this is the landscape we're operating. AI capabilities are advancing exponentially, costs are creating clear market dynamics, and developers are already integrating these tools into daily workflows. So the question actually isn't whether AI will impact Java development. It's how quickly, sorry, it's how quickly Java developers can adapt and leverage that capabilities. Now, let's look ahead to the next years and explore how Java will evolve in this AI-driven landscape. I also have a question I would like to ask for this section, and is if AI will replace software developers in the next decade. Please share your thoughts in the QA session. Here, I want to share 5 key trends that will shape Java's future, backed with EPAM's latest research and some market analysis. First, the AI power revolution. According to EPAM's 2025 predictions, 30% of development teams will accelerate their SDLC using AI tools by the next year alone. But here is what's exciting for Java developers specifically. We are seeing purpose-built AI tools emerging. Take as an example the EPAM's AI Code Explorer tool. This performs deep semantic analysis of code bases in different languages, including Java, and converts source code into a navigable multi-level graph representation. However, let me share a critical insight from our research. AI will enhance but not replace developers. Why? Because coding only represents from 15 to 25% of the entire development life cycle. So the real value lies in problem solving, architecture decisions, and understanding business requirements. And those things are uniquely human skills. So for software developers, you should think of AI as your intelligent pair programming partner and not your replacement. Second, we're entering the application generation era. Enterprise app generation platforms are maturing rapidly, and the major cloud providers, AWS, Microsoft Azure, and Google Cloud, are heavily investing in this space because they see the enterprise demand. This will fundamentally change how Java frameworks evolve. Spring, Quarkus, and other frameworks are already adapting to support AI-generated code patterns. So we'll see more opinionated frameworks that work seamlessly with AI generation tools. Now we can imagine describing a microservice in natural language and having a complete Spring Boot application generated for you. That's no longer science fiction. That's happening now. Again, the key question isn't whether this will happen, but how quickly Java developers will adapt to working alongside these generation tools. Third, platform consolidation, specifically in DevOps. My research shows that 50% of enterprises are moving away from best of breed tools change toward integrated platforms. This means standardization across build tools, testing frameworks, and deployment processes. So instead of managing Maven, Gradle, Jenkins, Docker, and Kubernetes separately, we'll see unified platforms that handle the entire Java application lifecycle. This consolidation will dramatically improve developer experience. This will make the onboarding times faster, reduce context switching, and will allow us to spend less time on tool chain management and do more of what is important, building great software. Fourth, the programming language landscape is shifting. Rust is climbing toward the top 10 languages, driven by memory safety requirements. Meanwhile, C and C++ usage is declining in new projects. But here is why Java remains strategically positioned. Uh, Remember the pillars changing Java DNA? Project Loom brings virtual threads for better concurrency. Project Panama enable seamless native integration. And the JVM continues innovating. But Java's real advantage isn't just technical, it's the ecosystem. Decades of enterprise libraries, proven scalability patterns, and the largest developer community in enterprise software. That's not easily replicated. So, looking toward 2030, here are my three key predictions. First, AI becomes the ultimate development accelerator, but the developers remain the architects and decision makers. Second, platform consolidation drives standardization. This will make Java development more streamlined and accessible. Third, Java maintains its enterprise dominance through continuous innovation and ecosystem strength. The future of Java isn't about competing with AI. It's about leveraging AI to build better software faster. And that future starts today. So, to sum up, the future of Java in the next decade looks both promising and dynamic, with ongoing enhancements and sorry, with ongoing enhancements. Java is well positioned to remain a leading language in the years to come. But the reality is that it's not about competing with AI. It's about leveraging it to build better software faster. Good. So now let's address the elephant in the room. While AI promises to revolutionize software development, the path isn't without significant challenges. Based on EPAM's extensive research and client work, I want to share the real obstacles we're facing and how to navigate them successfully. First, the reality check. AI isn't magic. According to industry data, 70% of AI project fails to meet expectations. Maybe you're wondering why. So let me share three critical issues we're seeing repeatedly. Hallucinations and errors. LLMs generate plausible sounding but factually incorrect code. In Java development, we have seen AI suggesting importing non-existing libraries. This creates a security vulnerability that attackers can exploit just by creating malicious packages with those made-up names. We have bias from training data. AI models reflect the biases in their training data, potentially generating discriminatory or problematic code patterns. And the black box problem. Even experts don't fully understand how these models produce results. This makes the bug and accountability extremely challenging. So, what's the key insight from here? It's that all AI outputs must be verified, especially in critical systems. AI serves as a tool that can generate certain suggestions, but you are the ultimate responsible for the actions taken from these suggestions. We're navigating a security and compliance minefield. Data leakage is real. When you send proprietary Java code to external LLM vendors, you are potentially exposing intellectual property and violating security regulations. We are seeing new attack vectors. Now, we have things like prompt injections that can circumvent security filters. Also, modern poisoning can corrupt AI behavior. And there is the constant risk of intellectual property infringement from training data. Regulatory complexity is exploding. AI native applications must comply with GDPR, HIPAA, and other regulations. So now bias monitoring and compliance automation is becoming more critical. This is why EPAM developed private fine-tuned models that keep your data secure while providing contextually aware suggestions. So the idea here is to maintain the control while delivering value. Technical debt and integration challenges. So legacy systems compatibility is a major hurdle. Many AI tools don't play well with the existing enterprise infrastructure, and this is creating technical disruptions. Code quality issues are common. Generative code often requires significant refactoring to fix non-existing methods, remove redundant logic, and align with business requirements. And sometimes it's not worth it to uh, pay off the cost of using an AI tool when you can be faster just doing it alone. The skill gaps are widening. There is a critical shortage of developers who really understand both traditional software engineering and AI integration. And complexity is exploding. AI native applications are exponentially more complex than traditional software due to advanced architecture, massive datasets, and the need to manage model-driven bias. And we still have the human factor that is often overlooked but critically important. First, the skill degradation risk. We're noticing an over-reliance on AI tools that could lead to developers not thinking as deeply. And this is problematic because deeper thinking remains the key differentiator between AI and humans. There are also, in certain occasions, team resistance. Um, Team resistance to change creates adoption barriers. This will increase the cost and the need for comprehensive training and just compound the challenges. And governance gaps. Governance gaps are emerging. We're seeing agent sprawl, fragmented AI ecosystems that are difficult to monitor and control. This also increases the security risk without a proper oversight. Deep thinking remains the key differentiator between AI and humans. So, how do we mitigate these challenges? Well, EPAM has developed a comprehensive approach. Our AI Factory Risk Management Framework. This is based on PMI standards, but adapted to AI's unique risk. It provides systematic risk identification and mitigation. The security-first architecture with private LLMs, comprehensive threat modeling, and built-in compliance controls. We should ensure also a responsible AI by design that ensure fairness, interpretability, and safety from the start, and not as an afterthought. And of course, continuous monitoring. Uh, we have some real problems that should be constantly monitoring, specifically model drift, performance degradation, and some security threats. Here is the fundamental truth. AI in software development isn't just about adopting new tools. It's about rethinking how we build software systems, how we secure applications, how we govern development processes, and how we manage technical risk. Success requires proper preparation, the right frameworks and methodologies, commitment to responsible implementation, and continuous learning and adaptation. The key is to navigate these challenges proactively and not react to the problems after they occur. So let me leave you with 5 key takeaways for challenge navigation. First, verify everything. AI outputs must be validated, especially in critical systems. Second, security first. Use private or local models and comprehensive threat modeling. Third, manage complexity. Prepare for exponentially more complex systems. Fourth, invest in people. Address skill gaps and change management proactively. And fifth, govern properly. Prevent agent sprawl with with proper oversight. The challenges are real, but they are manageable. We should only follow the right approach. And remember, success comes from preparations and not from reaction. So, based on my research and real world experience, I see three pillars that will determine success in the Java 2030 landscape. First pillar is embrace AI as enhancement. The future belongs to developers who leverage AI tools to amplify their capabilities, and not to those who see AI as competition. AI can handle the routine, and you will handle the creative and strategic decisions. Second, master the fundamentals. Deep thinking, problem solving, and architectural decision making remains uniquely human skills. As AI handles more coding tasks, these skills become more valuable, not less, because that is what differentiates us from AI. The developers who thrive will be those who can think at a higher level of abstraction. Third pillar is navigate responsibly. Success requires security first approaches, ethical AI implementation, and proper governance. The organizations that get this right will have sustainable competitive advantages. And those that don't will face compliance issues, security breaches, and technical debt that could cripple their entire development capabilities. Now, let me paint a picture of what success looks like in Java 2030. Developers spend 80% of their time on creative problem solving and architectural decisions, while AI handles routine coding tasks. Java applications are built faster, with fewer bugs, and with built-in security and compliance features. Enterprise development teams deliver business value at unprecedented speed, while maintaining the reliability and scalability that Java is known for. Java remains the backbone of enterprise software, not despite AI, but because of how well it integrates with AI-enhanced development workflows. The future of Java development isn't about choosing between human skills and AI capabilities. It's about combining them. Now, you have the opportunity to shape how AI enhances AI, how AI enhances Java development. You have the chance to lead the transformation in your organization and build the applications of tomorrow. Now the tools are emerging, the frameworks are being built, and the future is being written. So make sure you're part of writing it. This is Java 2030. Thank you.
Thank you very much for your talk. Yeah, I was I need some time to bring microphone here. So thank you very much. Um, I would like to highlight the topic which you brought during your talk, that Python is great for creating and training AI, and Java will bring it to the world. So that's really great. I think this is the thing which we should always keep in our heads, that Java is really great for integration and bringing things to world. So we have a question. Yeah. So thanks for the presentation, Andres. There is a view that current LLMs perform best when solving problems that follow known patterns or combination of patterns, and struggle when no established pattern exists. Some argue this may reflect a fundamental limitation of the current architecture or scaling approach, given the pace of progress. How do you see this evolving? Are we approaching the limits of what current LLM architectures can achieve, or is there still significant room for breakthrough in solving problems without known patterns?
Oh, sorry, I didn't follow up. The question was pretty long.
Sure. So let me try to make it shorter. So LLMs are great to solve the problems
Mhm,
with known patterns or combination of known patterns, but quite quite bad to solve problems where they need to figure something out from scratch, like without any patterns. So the
mhm,
question here is that given the pace of progress and given how fast LLMs are progressing, do you see this problem to be solved soon, or are we approaching the limits of current LLM architecture? And to solve these problems, we need to do something else. We,
mhm.
as humanity.
Okay. Yeah, now I got it. Thank you. Good. Well, I think it's a bit difficult because I will need to try to predict the future, and this is more like a personal opinion. As I was saying, what remains unique human skills are those strategic decisions, are that ability of solve that complex problem that hasn't been solved before, right? And that's where LLMs are not too good. Those new problems that didn't know about. So I think in the near future, that will still remain us, the humans, unique, and the LLMs will not, um, will be able to solve this in the near future. But when I am looking back and seeing how AI is progressing, how rapidly, how in just 2 years we're having models with the ability to solve PhD level scientific questions, uh, that makes me wonder if probably in the future, in the near future, we'll have LLMs that could tackle also those problems with new patterns. I think definitely we will get to that point where LLMs will be definitely get better solving those new patterns, those new problems. But I think at least for now, no.
Okay. Okay. Thank you very much for the answer and a lot of feedbacks. That talk is excellent, and thank you very much for it. I don't see any more questions, so I want to say thank you very much. Thanks for being part of Javon, and thanks for this amazing talk. Thank you very much.
Thank you all. I appreciate you having me, and I was pretty excited to share this topic with you all, guys.